Let's move on to question number 7 quickly. We have a junior doctor who prescribed flucloxacin 25 milligram per kg 4 times a day for the prevention of Staph aureus for a 10-year-old child. The child weighs 32 kg. Calculate the daily dose for this patient in grams. So the dose is already given. It's a fairly simple question. 25 milligram per kg, and the weight of the patient is given. And while I'm doing this, it just came to my mind to remind you that in some SPLE questions, you might be given the weight in pounds. The doses are calculated as milligrams per kg. So make sure that you are able to convert pounds into kg and then work out the dose if the weight is given in pounds. So 25 milligram per kg, weight of the patient is 32. So it's 25 multiplied by 32. So the dose would be 800 milligrams. And it's given as 4 times a day because we have to find out the daily dose. So it's given as 4 times a day. So simply 800 times 4 will be 3200 milligrams per day. So that's the daily dose. And also we have to find out it in grams. So let's just simply convert this 3200 milligrams into grams. So 3200 milligrams will be equal to, remember I'm going from a smaller unit to a bigger unit. Decimal is here, which will move towards the left by 3 places. So that's 1, 2, 3, and that will be 3.2 grams per day. And that's the answer. Moving on to question number 8, we have a prescription for Dermovate ointment for 0.5% weight by weight. What is the amount of liquid paraffin I would need to add to 2% weight by weight Dermovate ointment in order to prepare 10 grams of Dermovate ointment 0.5% weight by weight? So it's if you look at it carefully, it is again a simple C1V1 C2V2 question, but actually the question is asking about something else. What is the amount of liquid paraffin, which is the thing which I would dilute the active drug with? So let's apply C1V1 C2V2 first, and then we'll see what else the question is asking. C1V1 C2V2. So I have to make 0.5% of the cream, and I have to make 10 grams of it. 10 grams of this 0.5% I have to make. And the starting cream which I have to take, which I will dilute to make it, it will be 2%. So that's given here. So 2%, and let's calculate what would be the volume or the amount of this starting or initial cream I would take to make this preparation. So let's just simply solve this equation first. .5 grams. So that means I need to take 2.5 grams of this. I need to take 2.5 grams of this 2% cream, and I will dilute it, and it will become 0.5% of 10 grams of the full cream. So if you see the final volume of the cream, or the final amount of the cream, is 10 grams, right? So that's the final amount of the cream. But I'm taking but I'm going to take 2.5 grams of 2.2% cream to start with. And because I have to make it up to 10 grams, so simply 10 minus 25, so 10 minus 2.5, 7.5 grams. So that means I will take 7.5 grams of the liquid paraffin cream. So that means I will take 7.5 grams of liquid paraffin, and I will mix it with 2.5 grams of 2% cream, and the final product will be 10 grams, and its concentration will be 0.5%. Let's move on to question number 9. It's a very interesting question and a bit long calculation, so you just need to pay attention. We have a 60 kg patient here who has been prescribed 30 milligram per kg of epilim IV 400 milligram per 4 mils. Which one of the following is is correct. So we have been given 4 options. It's like an MCQ. So epilim dose for this patient is 0.18 grams. So let's calculate what's the dose of this patient. Dose is 30 milligrams per kg, and we have been given the weight of the patient. So that's 30 times, weight of the patient is 60. So 30 times 60 is 1800 milligrams. And in milligrams, it would be 1.8. So the dose of the patient given is 1.8. So option number option A is saying the dose of the patient is 0.18. So that is incorrect. So A is wrong. Let's have a look at B. Volume of injection required for a single dose is 1.8 mils. So I have to give 1.8. Now I have to find out how many mils of the injection will contain this 1.8 grams of the dose. So I will simply make use of this information, which is the concentration or the strength of the injection. So if the strength of the injection, it is saying that 400 milligrams present in 4 mils, then 1800 milligrams from here will be present in how many mils? So that would be 4 divided by 400 times 1800. So that would be 18 mils. So that means the dose of 1800 grams, which I have to calculate, which I have to give, that will be present in 18 mils of this injection, and here it's given 1.8. So that's wrong as well. So B is wrong. Let's move to option C. It says if you need to produce 100 milliliter of the infusion, so that's the final volume of the infusion, then the amount of normal saline needed to produce will be 82. But actually, if you look at it, you will see that the amount of the drug or the amount of this injection I will take is 18 mils, right? Because this 18 mils is going to have this 1800 milligram dose. So I would take 18 milliliters of the injection, and in order to make 100 mils of infusion, I would add, to make 100 mils of infusion, how much I would add, how much normal saline I would add. So that would be simply 100 minus 18, that's 82. So I will take 18 mils of the injection and I will mix it with 82 mils of the normal saline, so that the final volume of the solution will be 100 mils. So I need to take 82 mils of the 100 normal saline. So that's what it's given here. So C appears to be the best answer at the moment. So but let's have a quick look at the option number D also. The number of vials required to prepare single dose would be, so let's just see this. So if 400 milligrams present in 1 vial, 1800 milligrams will be present in simply 1800 divided by 400. So I will need 4.5 vials. Because these are number of vials, so let's just round it up and make it 5 vials. So 5 vials, here it's given as 4. 4 vials are not going to provide the sufficient dose, so that means D is all wrong. So C is the correct answer here. Move on to last question finally of the mock test. Here we have the patient who is admitted to the hospital with an overdose of drug X. The plasma concentration of the drug at admission is 140 mcg per liter, and the drug's half-life is 4 hours. Assuming that the absorption is complete and the elimination occurs by first order kinetics, what will be the plasma concentration after 12 hours? So we have got the initial plasma concentration to start with, and we have got the final half-life of the patient, half-life of the drug, and we have to find out how much of the drug will be left after 12 hours. So when the patient came in or the starting concentration, it was 140 mcg per liter. So because it's first order kinetics, and assuming that absorption is complete, so after first half-life, 140 mcg will be reduced to half, so that will be 70 mcg per liter left. After second half-life, this 70 will be reduced to half, so that will be 35 mcg per liter. And after the half-life, this 35 will be reduced to half, 17.5 mcg. So after this is after first half-life, this is after second half-life, this is after third half-life, and every half-life is about 4 hours. So 4 hours, after 4 hours, after 4 hours, and 4 hours means after 12 hours. So I can see here that after 3 half-lives, or in other words after 12 hours, the amount of the drug, the concentration in the plasma concentration of the drug will be reduced from 140 mcg to 17.5 mcg per liter. So it's a fairly simple calculation, but you need to understand what's going on in the question. I hope that was clear.